Hello everyone, today I'm going to cover TCP IP model. First of all, what is TCP IP model? We will discuss some brief points about it. So TCP IP model is an layered approach. So it is a layered approach. It have multiple layers and basically it is a reference model. Now, what do we mean by reference model is that whatever protocol, whatever device which will be designed or programmed, it will be designed on the basis of TCP IP model nowadays. It was developed by DRDO, US, and basically we can say that whenever a device or a protocol is designed or made, it is done with the help of TCP IP model. What will they do is they will take a reference from this TCP IP model. Basically, these layered approach were used so that we can achieve interoperability in between the devices of different vendors. Now, there are two TCP IP models if we talk about. The first one is, or if I'll compare the TCP IP model with the OSI model, I'll write down the names. OSI model. After that, we have TCP IP original model. It is TCP IP. After this, the TCP IP original model was updated, and right now it is the current TCP IP model which is used is the updated model. So there are 7 layers in OSI. I hope you know about all these 7 layers. If I'll start from top, the name would be application layer. After that, presentation. Then session layer. After that, transport layer. Then it will be network layer. Then it will be data link layer. And the last one would be physical layer. Now, in this scenario, if I'll talk about TCP IP original model, it had only 4 layers. Only 4 layers. And the name of these layers is the first 3 layers were combined in TCP IP model and they came up with application layer. After that, transport layer is as it is used. Then we will have network layer, and in place of network layer, the name is internet layer. After that, there will be only single layer for data link and physical, and the name of that layer will be network access layer, right? So, and TCP in this TCP IP model, transport layer is also known as in some of the books, it would be referred as host to host, right? So these are the 4 layers in TCP IP original model, but they updated this model, and right now there are 5 layers in this updated TCP IP model. Right now, you will see this model used in all the devices and protocols. I'll show you in the packet captures right now. So the 5 layer, the name of these layers are application layer, transport layer, after that internet layer, All are same. Just the thing is that the access layer was converted into two parts. The first one will be data link layer, and this one is data link DLL. Data link layer, and the last one will be physical layer. So now I will not tell you that what is the work of each layer. You must have studied it in the OSI model and TCP IP model and CCNA. Just a brief introduction is something like the application layer will be used for the host to host communication. It is used to provide the services like web service, file transfer service, remote access service, management service, time service. After that, transport layer is basically it deals with the TCP and UDP protocol for the reliable and unreliable transmission of the data. Network layer deals with, or internet layer basically deals with the layer 3 stuff like routers, routing protocols. Some of the routing protocols used in the internet layers are like OSPF, EIGRP. After that, IPv4 and IPv6. These are used at network or internet layer. After that, GRE is one of the protocol which is used at network layer or internet layer. Then we will talk about data link layer, which deals with the not physical transmission of data. Basically, MAC addresses are used and layer 2 devices like switches are used at this layer. Layer 2 switches, or we can say bridges, will be used at this layer. Protocols like ARP, Address Resolution Protocol, Spanning Tree, DTP, VTP, all these protocols will be used at this layer. And this is also one of the layers which is divided into two subpart. It would be LLC and MAC. LLC and MAC. Media access control and logic link control. After that, physical layer deals with the transmission of data, physical transmission of data. So this is the TCP IP model, a brief introduction. But how I'll prove that right now or in today's world TCP IP updated model is used? Let's take an example. Now what I'm going to do is I'll take two routers and I'll enable telnet on one of the router, and we will capture some packets in between these two routers. So when we will capture the packets in that scenario, you could see that TCP IP updated model is used nowadays because you could recognize easily each layer. Each layer can be recognized easily. Let me open the that pen. What was the name? Epic pen. I have started all the devices, router 1 and router 2. I'm going to connect them. I hope you are aware of GNS3. It is one of the tools which can be used for the routing practicals. I'll connect router 1 and router 2. I'll provide IP address to these routers, something like 10.1 and 10.2. It's not let's take it simple. And what I'll do is I'll enable telnet on this router number 2. Sorry. And I will access router number 2 from router number 1. Let's do it. First of all, I'll take access of router 1. See, this is router 1, global configuration mode, interface fast Ethernet 0 by 0. See, the interface number is 0 by 0 fast Ethernet, no shutdown. IP address here will be 10.1.255.0.0. It is the subnet mask, right? After that, I'll take access of router number 2 and I'll give the IP address as 10.2. You can see in the host name it is written R2, router 2. The command will be interface fast Ethernet 0 by 0, no shutdown. IP address will be 10.2. After this, I'll enable telnet on router 2. Now, if you don't know how to enable telnet, please join CCNA classes. The command to enable telnet is, first of all, on enable mode, I'll set password. After that, line VTY024, then password, and I'll enter login, right? Apart from this login, I could have also used login local. Now, what is difference in between login and login local? Write down in the comments. You must know about it after this. So these are the commands to enable telnet on a router. I have enabled telnet. Now, before trying to access router 2 from router number 1, I'll start Wireshark or the packet capture on router 2 fast Ethernet 0 by 0 interface. Let's do it. I think I'm unable to do it. System cannot find the file specified. Let's wait for it. So guys, I have started the Wireshark to capture the packets in between router 1 and router 2. So let's first of all ping from router 1 towards router 2. I'll enter the command 10.2. Let's see if we can ping. Yes, we can ping it. And in Wireshark capture also you can see the ICMP packets, right? Now, what I'll do is I'll telnet from router 1. I will telnet 10.2. The password is 123. I have access of router number 2. See, earlier we were on router 1. After telnet, I can have the remote access of router 2. But I did not wanted to show you this. What we have to see is this. These are some of the TCP packets of Telnet, TCP and Telnet packets. We want to capture this. We want to see these packets. Now I've stopped Wireshark. Now before opening up these packets, you must be aware of TCP IP model. As I told you, there are 5 layers. Now, first of all, if we are using Telnet, Telnet application will be used at which layer? Application layer. This telnet traffic will be encapsulated in TCP header, which is used at which layer? Transport layer. This transport layer will be, or the traffic will be encapsulated in IPv4 header. Now, this complete traffic will be encapsulated in layer 2 with the help of which header? Ethernet 2 header. And then this complete traffic will be converted into bits and transmitted through our transmission medium. So there are 5 layers in use, right? Now I'll show you in the packet capture that if I'll take this telnet traffic, I'll open it up. This is the first packet, and you can see that there are only 5 layers used. Application layer telnet, transport layer TCP protocol, transmission control protocol. The internet layer will use IPv4, data link layer will use Ethernet 2 header, and then it will be converted into bytes and transmitted through the wire. That is why I am saying that today, in today's devices, TCP IP updated model is used. Now, I can open up these packets. Let me show you. So this one is the application layer telnet traffic, TCP, which is used at transport layer. Let's see the content of TCP header. In TCP header, what it is showing us, source port number is random and the destination port number is 23. Now everyone must know about the 23 port number. 23 port number is used for telnet, right? After that, sequence number is 1, acknowledgement number is 1. Flags. How many flags are there in TCP header? There are 8 flags. Let me name them. Let's name them one by one. Flags. How many flags are there? The first one is What is the first flag? SYN. Second one is ACK. Third one is reset. Fourth one is push. Fifth one is not pop. Push flag, urgent flag. After that, there is one more flag known as finish flag, FIN. And the other two flags are explicit congestion notification, ECN, and the eighth flag is CWR, congestion window reduce. Explicit congestion notification echo. The name is echo. Now ECN stands for, let me write it down, notification, and CWR stands for congestion window reduce. Right? And after this, so these are the eight flags which can be used. Now, the use of these flags, SYN plus ACK, it will be used in three-way handshake, right? Three-way handshake is done in TCP. So SYN plus ACK will be used there. Reset flag will be used to reset the session of TCP in between the source and destination. Push flag is used to forward the traffic to the upper layers like session, presentation, and application. Urgent flag when we want to use urgent pointer field in the TCP header. At that point, urgent flag will be used. Fin flag will be used to terminate the TCP session. It is used in four-way handshake. Now you must be aware of four-way handshake. It is used for terminating the TCP session. Yes, there is three-way handshake. To make the connection and to terminate the connection, four-way handshake will be used. After that, explicit congestion notification echo and congestion window reduced will be used for which purpose? It will be used for congestion in the network, right? Now, what is congestion in the network? Congestion means to say like if from source to destination there will be multiple devices, right? Like let's say we have one source and one destination, and there will be multiple devices in between. If this traffic experience any congestion in between these devices, at that point of time, these two bits will be used, explicit congestion echo and congestion window reduce, right? So these are the headers. We can see them in, yeah, we can see them in Wireshark. See, I'll open up these flags. So basically, first two fields are reserved. They will be always zero. Nouns and reserved, these are the four bits. These will always be set to zero. After that, congestion window reduced, explicit congestion notification echo, urgent acknowledgement. Now, ACK stands for acknowledgement, push set for push is as it is, sorry, it do not stands for anything. Now push flag, why it is used? So that the traffic can be forwarded towards the upper layer, application layer. See, we are using application over here. Telnet is used, so that is why push flag is on. Reset is used to reset the session in between source and destination. SYN stands for synchronization and fin stands for finish. All the bits are set zero, only acknowledgement and push are used in this traffic or in this header. So this is why flags are, this is how flags are used, not why. And after that, window size, by default window size is always 4128 bytes. All this is covered in CCNA videos. You can see it from there. After that, we have urgent pointer field. It is not used. That is why urgent bit is 0. And the payload is of 12 bytes. This payload size is of telnet. This complete information is in the TCP header. You must be aware of each and every field of TCP header. After that, it will be encapsulated in the IPv4 header. Version 4. Header length will be 20 bytes IPv4. Now DS DSCP field, it is used for the quality of service. Total length of the traffic is 52 bytes. After that, identification flags and fragment offset. This portion, these three fields will be used for the fragmentation process. Fragmentation, if at layer 3 router is performing fragmentation, then these three fields will be used. Now, how many flags are there in the IP header? Only three flags. The first flag will always be reserved. You will always see it as 0. After that, MF stands for more fragment. And the last one is DF. Now, DF stands for don't fragment. So why these fields are or bits are used for the case for the fragmentation process. After that, TTL value, time to live, it is 255 for which devices? Cisco devices. Now, TCP header is used at layer number 4, transport layer. TCP is used, its value, its protocol number will be 6. If we are using UDP at layer 4, at that point of time, its protocol number will be 17. Source IP, destination IP address. So all the information is given over here in the IPv4 header related to the routing stuff, you can say that. After that, Ethernet header. This IPv4 will be encapsulated in Ethernet header. It will have source MAC, destination MAC, and the type value indicates IPv4. So for IPv4, the type value will be 0x0800. Let me remind you guys, if in front of any digit you will see 0x, that means the numbers ahead are hexadecimal numbers, right? So this is the complete packet which will be then converted into bits and bytes on wire, and then it will be transmitted towards the destination device, that is router 2. This is how traffic is being forwarded in between these routers. I hope you got this. Now everyone, the next topic for the discussion is, so basically as I told you we will be doing switching. So the next topic will be VLANs, right? Now, what are VLANs? Virtual Local Area Network. Now, what does VLANs do? See, to understand VLANs, first of all, you must know that what is a work of switch. Basically, switches are used to connect the devices in same network, right? For example, if I'll make a switch, I'll connect some devices. This is our switch 1. This will be PC1, this will be PC2, and this will be PC number 3. Let's say all these devices are connected. Now, one thing is that you must know that a switch is in single broadcast domain, or we can say all the devices which are connected to a switch will be in single network or in the same network, right? If I want to create multiple networks on a switch, what I'm going to do is, for example, PC1 and PC2 must be in different network and PC3 must be in different network. In this scenario, what I'll do is I'll divide a switch into multiple broadcast domains. Now, what will VLANs do? VLANs will divide the. Done. What it will do is it will divide the broadcast domain. on a switch. That means now we can have multiple networks on a switch. Like this is a switch, right? Now on this in this scenario, PC1 and PC2 can be on different network 10.0.0.1 and PC2 IP address will be 10.0.0.2. PC3 will be 20.0.0.1. This is the use of VLAN, right? But PC1 and PC3 will not be able to communicate with one another easily. Now, how many VLANs are there? Let me tell you. There are two types of VLANs. Standard VLANs, extended VLANs. Standard VLANs will range from 1 to 1005 and extended VLANs will range from 1006 to 4096. Now, over here, some VLANs are reserved which cannot be used. For example, VLAN number 1, it is known as default VLAN. So you cannot delete VLAN number 1 from a switch. It is by default created and all the interfaces are by default in VLAN 1. After that, from 1002 till 1005, these VLANs are also reserved for FDDI and token ring technology. So we will not use these VLANs. Apart from it, all the other VLANs can be used on a switch. Extended VLANs, basically, we are not using extended VLANs also because there is no need to create extended VLANs on switch. Now, if we want to create a VLAN on switch, I'll do a practical on Cisco Packet Tracer. Let's see. This is Cisco Packet Tracer. What I'll do is I'll take a switch, then I'll take two PCs. I'll connect these switches with this PC, these PCs with switches. I'll take the IP address as 10.1 on PC1. Then I will take PC2. IP address will be 10.2. Now, this is switch number 1. Enable. See, this is a fresh new switch. I have not configured anything on this. Show Run the command show VLANs or show VLAN brief. You can use any command. By default, on this switch, some VLANs are created. VLAN number 1 default from 100 till 2005. FDDI token ring, FDDI token net. So these four VLANs are by default used. We will not delete them or use them. Apart from it, we can create any VLAN. And as I told you, all the interfaces of switch will be in VLAN 1. See, all the interfaces fast Ethernet 0 by 1 till fast Ethernet 0 by 24 is in VLAN number or are in VLAN number 1. Now, one important thing, how can we create VLAN? Very easy. Command is in global configuration mode, you will enter VLAN number, you will give name like I have given name IT. I'll exit it. VLAN is created. Do show VLAN. This is how VLAN can be created easily. Now, one more thing. See, VLAN number 10 is created. It is active, but no interface is part of this VLAN, right? Now, whenever you create a VLAN, in switch flash memory, there is a file which is known as VLAN.dat file. If I'll enter show flash, see, you can see that VLAN.dat file is created. Basically, what happens is whenever you create a VLAN, this VLAN will get automatically saved in this file, VLAN.dat file. The size is 616 bytes. Whenever you will create a single VLAN, its size will be increased by 60 bytes. Let me show you an example. Global configuration mode, VLAN number 20, exit. After that, do show flash. When VLAN 20 was created in Flash folder or in the flash memory, VLAN.dat file size increased by 60 bytes. Earlier it was 616, now it is 676. So that means a VLAN will take 60 bytes of size in your flash memory, and it will always go in which folder, in which file, VLAN.dat file. So whenever you are using an old switch in your network, you will always delete this file. It is mandatory, right? After so these are the commands to enable VLAN on a switch. But now I want to make this fast Ethernet 0 by 2 part of VLAN number 20, right? What I'll do is whichever interface you want, or you want to change VLAN on whichever interface, you will take that interface. I'll use the command interface fast Ethernet 0 by 2. What I'll do is I'll enter two commands to change the VLAN on this interface. Switch port mode access, switch port access VLAN number 20. See, so this command says that on fast Ethernet 0 by 2, the switch mode is changed to access, and this switch port access is in which VLAN? VLAN number 20, fast Ethernet 0 by 2. You can verify it with the help of command do show VLAN. See, 0 by 2, it is present in which VLAN? VLAN number 20. Now it is in different broadcast domain. So PC1 will never be able to communicate with PC number 2. You can try it. Ping 10.2. See, we will never be able to ping it. Reason is very simple. Fast Ethernet 0 by 1 is by default in VLAN 1, and fast Ethernet 0 by 2 will be in VLAN 20 as we made it. Right? So broadcast domains are different. The traffic will never be forwarded by switch from one VLAN to another VLAN. It can never be done. Got it? So this is how you can create VLAN on a switch. Now, after this, see, if I want to see that what are the properties, layer 2 properties of an interface, I can use command show interface fast Ethernet 0 by 2. This command will tell me the properties of this interface. Like the interface is up, the MAC address, layer 2 properties. MAC address is this for the particular interface, bandwidth, delay, reliability, load. After that, which encapsulation is used, full duplex or half duplex mode, what is the speed of this link, 100 Mbps, 10 Mbps, right? All this information will be in this command. But if I'll enter this command and write switch port in front of it, it will show me complete information of the VLAN stuff. When I have entered switch port in front of this, see, the name of this interface is fast Ethernet 0 by 2. Switch port is enabled. That means layer 2 features are enabled for this switch, for this port. What is the mode? Static access. This interface is part of which VLAN? VLAN number 20. So all this information can be seen with the help of switch port command. It is very important when you are using it, when you are using a switch in a live environment, it will be used again and again. You must make a note of this command, right? After this, yeah, so this will be all about VLANs, how we can troubleshoot it. So which all commands we have used to troubleshoot VLANs? Show VLANs, or in place of it, you can also use show VLAN brief. After that, show interface, fast Ethernet 0 by 2, whatever interface you want to use, and show interface, fast Ethernet 0 by 2, and you have used switch port. Right? So these are the commands which can be used to troubleshoot a VLAN scenario. Done. Now, everyone, at the last of this video, there is one interesting question which is asked in interviews. Let's say, comment the answer if you know it. At least try it out. It's very interesting question related to VLANs. It was asked in one of the interviews from me, and it is regularly asked. Very easy. Let's say I have a switch. This is my PC1, this is my PC number 2. After that, the IP address of this PC is 10.1/8. The IP address of PC2 is 10.2/8. So normally you will be able to ping these PCs, right? From PC1 to PC2, you will be able to do it. How you will be able to do it, I'll tell you because by default, both the interfaces of of this switch is in VLAN 1, right? Both the interfaces are by default in VLAN 1. That's why switch will be forwarding the traffic towards this. As I have told in the previous video, you must be aware that a switch will always learn the show MAC address table. See, in show MAC address table right now it is not having anything. Let's ping. If I have pinged from one PC, see the MAC address table, you will be able to see that switch will learn MAC address, but it will also learn VLAN. So the traffic is coming from VLAN number 1, right? Fast Ethernet 0 by 1. So what I was telling is switch will always learn the VLAN also for the particular port. Both the interfaces are in VLAN 1. That's why we were able to communicate. But if I say that this interface is in VLAN number 10 and this interface is in VLAN 20, the first question is, will these PCs be able to communicate with one another? You know the answer. We have covered this answer in the video, but now the next question is, they will say we want PC1 and PC2 communicate with one another. How you can do that? Answer it in the comments. Very interesting. Let me remind you one thing. Don't think of inter-VLAN routing. No, if you know inter-VLAN routing, very good, but it will not be used here. Why? The reason is that see the IP addresses. 10.1, 10.2, both are in same network, same subnet mask, right? So inter-VLAN routing will not be used because inter-VLAN routing can be used if we want to communicate in between different networks. How PC1 and PC2 can communicate? Answer it.